Hello, it's Harry here. So this is part 2 of my video about how to use our Shiny app to create AE tables. So in the part 1, we have discussed our Shiny app, which can create some AE tables for us. But there is an issue with that our Shiny app. And the issue is that we specified the values of the treatment variable in the R program. So the values are placebo and active. So if you want to run that R program on the data sets from another study where the treatment variable takes different values, that R program is not going to work. So in this video, I want to discuss how to make some improvement on the R Shiny app. Okay, so let's take a look at the data sets first. In the screen, I have a small R program. It's using the library Haven to read some SAS data sets. So let's run this program. Okay, in the ADAE, you can see the first column is a treatment variable. It takes a value active treatment A and active treatment B. And then you have the use of the ID and the safety flag. Okay, if we look at the ADAE, you can see the first variable is a TRT01P. It takes a value active treatment A and active treatment B. And you have the use of the ID, you have preferred term AEDCOD. You have system organ class, you have a high level term here, and you have the treatment emergent flag and the safety flag. Okay, so let's look at the app. So how do we plan to improve the R Shiny app? The idea is that we don't want to specify the values of the treatment variable in the R Shiny program. We want to ask the user to specify those values. So we're going to ask the user to provide a CSV file, and the user can put the values of the treatment variable in the CSV file. Okay, so before we run the app, let's take a look at the CSV file. Okay, so you can see this CSV file, it has 2 rows and 2 columns. The first column is number 1 and 2. The second column is active treatment A and active treatment B. Okay, so let's run the app and see how it works. Okay, so there are several tabs here. First one is to input the CSV file. So let's do that. Okay, then we upload the ADSL, upload the ADAE. Okay, then we click on this one level. Okay, so you get the AE table for preferred term. You have the active treatment A, active treatment B, and total column. You have the count and percentage for each treatment. If you click on the 2 levels, you have the AE table for system organ class and preferred term. The system organ class is in light gray, and you have the 3 treatment columns. If you click on 3 levels, so you still have the 3 treatment columns. This AE table is for the system organ class high level term and the preferred term. The system organ class is in dark gray, the high level term is in light gray, and preferred term is in white. Okay, so it looks good. Before we look at the app, I want to note one thing. So in this CSV file, the user can specify the treatment in different order. So if the team wants to see active treatment B on the left and active treatment A on the right, so he can just change the values of this treatment. Okay, so let's save this. Okay, now let's run the app. Upload the CSV file, upload ADSL, upload ADAE. Okay, so now we can see the active treatment B is the first treatment column, the active treatment A is the second column. Similarly, we have the 2 levels AE table, 3 levels AE table. Okay, so this CSV file is very useful. Let's see how the program works. So at the beginning of the program, we have this libraries. We need a library haven to read the SAS dataset. We need the Shiny and the Shiny themes for the app. We need the tidyverse package. We're going to use some functions from that package. We need the GT package. We use this to create a table. Okay, so in this line, we put the date into the variable, the date. This is going to be used in the footnote of the table. Okay, in the UI part, we specify those names for the tabs. So we're using the tab panel here, and this tab is input CSV file, and here we have upload the ADSL. Here we have upload ADAE, and we have the 1 level, 2 levels, 3 levels. Okay, so now let's look at the server part. So in the server part, we have return table 1. This is for the AE table for preferred term. And we have the return table 2 for the 2-level AE table, and the return table 3 for the 3-level AE table. So they are very similar. We will only look at this return table 1 in some detail. Okay, so we start with reactive programming here. First, we use this read.csv function to read the CSV file. We put the information into this raw data. And what we're doing here is we use this condition. The first column is equal to 1 to get a subset of the data, of this raw data. And we put the information in the second column into VR1. So this is the value of the treatment variable. We put it in VR1. Similarly, we put the value of the treatment variable in the second row in VR2. So we're going to use these two variables later on. Okay, so here we use the read sets function to read the ADSL and ADAE. What we're doing here is we're using some conditions to get a subset of ADSL. Here we use this filter function. The condition is the treatment variable is equal to VR1 and the safety flag is Y, and we create a subset of the ADSL. We call it ADSL1, and we create a new variable GRP, and we give the value GRP1 to this variable. And here we create ADSL2. This is for the second treatment, and we have ADSL3. This is for the total column. And then we use the rbind function to concatenate these 3 ADSL datasets that we just created. Okay, in the next few lines, we are doing the same thing, but we are doing it for the ADAE. We create some subsets and we combine them together. We have a new treatment variable GRP. Okay, here we are using the table function to count the number of patients in each treatment group. This is going to be used in the column header. Here we're using the summarize function. First, we use the summarize function with the group by GRP. So we get a count of the patients with at least 1 TEAE in each treatment group. Here we're using the summarize function, but with the group by GRP and AEDCOD. So we get a count of patients in each treatment group and for each preferred term. Okay, now we use the spread function to transpose the A1, to transpose the datasets. We put it in A1 and A3, and then we use the C function to keep only certain variables, and we use the rbind function to concatenate the A1 and A3. Okay, after this step, we sort the dataset. This order minus final $GRP3, this means we want to sort the final dataset in a descending order in the total column. So GRP3 is for the total column. Okay, the next few paragraphs we're calculating the percentage and put the percentage and the count together. So this step we divide the count by big N. So this is for the percentage. We use the format function to keep only 1 decimal in the percentage. We use the paste function to combine the count and percentage. This if-else function, we use this to handle the situation where the count is missing, so we assign a 0 to it. Okay, so these 4 lines are for the first treatment, and the next 4 lines are for the second treatment, and these 4 lines are for the total column. Okay, and then we use this C function to keep only 4 variables. Now we are ready for reporting. We're going to use the GT package. We have the table header, we have the source node, we have the columns label. So we note here that in the columns label, we have to specify the treatment. So we have the VR1 here, the VR2 here, and the total here. Okay, after this, we use a render GT function. Use the render GT function to create the AE table. Okay, it's pretty straightforward. So this app can create the AE table. It reads the values of the treatment variable from the CSV file. This app can still be further improved. The limitation of this app is that it's assuming that there are only 2 values in the treatment variable. So you can see that's right here. We have VR1 and VR2. In some studies, the treatment variable can take 3 values or 4 values. So for that kind of study, this app doesn't work. So I'm going to discuss how to improve this app in the next video. So ideally, we really want to create a Shiny app that can read the CSV file, count the number of values in the treatment variable, and act accordingly. So we're going to do that in the next video. Okay, I think this is it for this video. I'm going to put the datasets and R programs in my GitHub account. I will leave a link in the description of this video. If you find this video helpful, please give it a thumbs up and consider subscribing. Thank you.